It began with a whisper, then silence. A profound, unnerving quiet descended upon NASA's Ames Research Center. Specifically, within the heavily shielded walls of the Quantum Artificial Intelligence Laboratory. This was no ordinary power outage, no simple system glitch. The date was marked May 12, 2025, an ordinary Tuesday, until it wasn't. The air, usually thrumming with the hum of cryogenic coolers and the energy of brilliant minds, became heavy. Still. The scientists, the engineers, the very guardians of this nascent technology found themselves locked out. Not by doors, but by data. Screens went blank. Communication channels with their most advanced quantum processors ceased. It was as if the machines had decided to stop, to contemplate. The silence was not empty. It was full of questions, full of a sudden, chilling uncertainty. This facility housed some of the most advanced quantum computing systems on Earth. The shutdown was abrupt, total. No warning signs, no error codes, just a sudden, inexplicable caesura in the symphony of computation. The official statements were vague: ongoing diagnostics, system recalibration. But the hushed tones and furrowed brows of those emerging from emergency meetings told a different story. Something unprecedented had occurred. To grasp the magnitude of this event, we must journey into the quantum world. Imagine a normal computer bit. It's either a 0 or a 1. Simple. Definite. Now picture a qubit, the quantum bit. It can be a 0. It can be a 1. Or, thanks to superposition, it can be both 0 and 1 at the same exact time. Think of a spinning coin, neither heads nor tails until it lands. This ability to exist in multiple states at once is the heart of quantum computing's power. It allows a quantum computer to explore a vast number of possibilities simultaneously. Where a classical computer tries one path, then another, a quantum computer can try countless paths all at once. This opens up computational capabilities that were once confined to the wildest dreams of theorists. Then there's entanglement. Imagine two qubits, linked, entangled. Whatever happens to one qubit instantaneously influences the other. This interconnectedness allows for an exponential increase in processing power. Each new entangled qubit doesn't just add to the power, it multiplies it. These qubits, these superpositions, these entanglements, they are the building blocks of a new kind of computation, one that promises to solve problems currently intractable for even the most powerful supercomputers we possess today. The implications of mastering quantum computation are not just academic, they are revolutionary. Consider medicine. Designing new drugs is a complex dance of molecular interactions. Quantum computers could simulate these interactions with perfect fidelity, creating targeted therapies for diseases like cancer or Alzheimer's. Personalized medicine, tailored to your unique genetic code, could become a reality. Think of materials science. We could design new materials with unimaginable properties. Superconductors that work at room temperature. Lighter, stronger alloys for spacecraft and everyday objects. Materials that can self-repair. Or capture carbon dioxide directly from the atmosphere with incredible efficiency. Cryptography, the science of secret codes, would be transformed. Many of our current encryption methods rely on the difficulty of factoring large numbers. A sufficiently powerful quantum computer could break these codes in hours or even minutes. This presents both a challenge and an opportunity. And then there is the universe itself. Quantum computers could help us simulate the birth of galaxies, the behavior of black holes, the nature of dark matter and dark energy. The quest to understand our place in the cosmos would gain an incredibly powerful new tool. This immense potential has ignited a global race, a competition for quantum supremacy, the point where a quantum computer outperforms classical ones. Nations and corporations are investing billions. The brightest minds are being recruited. The stakes are incredibly high. Google claimed quantum supremacy with their Sycamore processor. It performed a complex task in minutes versus 10,000 years for Summit. This signaled the dawn of quantum computation. The pursuit of quantum supremacy drives innovation. Back at NASA Ames, the silence that fell on May 12th was more than just a technical glitch. The initial explanations of diagnostics began to wear thin as days turned into weeks. The perimeter around the quantum lab tightened. Information became a scarce commodity. This level of secrecy was unusual, even for an institution accustomed to handling sensitive projects. It fueled speculation. It hinted that what had happened was not merely a shutdown, but perhaps a discovery, or an interaction. What if the quantum system, in its silent computation, had stumbled upon something unexpected? The nature of quantum mechanics allows for possibilities that stretch the imagination. Could the machine have achieved a level of complexity, a form of nascent awareness that its creators hadn't anticipated? This is pure speculation, of course, but in the quantum realm, the line between science fiction and potential reality can sometimes blur. The teams working on these systems are pioneers. They are charting unknown territory. Perhaps the silence was a precaution, a necessary pause to ensure that they fully understood the implications of a new threshold that had been crossed, or to protect what they had found, or to protect themselves from it. The global quantum community watched and waited. The mystery only deepened with each passing day. Now, we venture into more speculative waters, but science often begins with speculation, with what if. Quantum mechanics hints at a reality far more complex than our everyday experience suggests. One of the most intriguing interpretations is the many worlds interpretation. It suggests that every quantum measurement causes the universe to split, creating parallel universes. Could a sufficiently advanced quantum computer detect these other realities? This is far beyond current capabilities. Yet, the theories exist. If such realities are out there, a quantum system might detect their faint whispers. Imagine the implications. The silence at NASA's quantum lab serves as a powerful reminder. We stand at the precipice of a new era, an era defined by our ability to harness the fundamental forces of the universe. Quantum computing is a key that could unlock answers to questions we have barely begun to formulate. It promises a deeper understanding of reality itself. The path forward will be filled with challenges and moments of profound mystery. But humanity's spirit is defined by its relentless pursuit of knowledge. We are explorers by nature, driven by an insatiable curiosity. To understand the stars above and the quantum world within. Whether the recent events at NASA herald a breakthrough or a complex technical hurdle, they underscore the transformative power we are beginning to wield. The quest for quantum supremacy is more than just a race. It is a testament to our ingenuity and our unwavering belief in the power of reason and discovery. The universe is vast, and its secrets are deep. And so, we continue. We observe. We theorize. We build. We explore. The journey into the quantum realm is just beginning. Its echoes will reshape our world, our understanding, our very future. The universe has been speaking to us in the subtle language of quantum mechanics since the dawn of time. We are, at last, learning how to listen.